Hey everyone, welcome to the video. Today we're going to be doing the AP Calc BC 2016 exam FRQ number 1. And this is actually an AB question, but it's on the part of the BC exam. So without further ado, let's get into it. As always, I have the question pulled up next to me, so if you want to follow along the best, I'd recommend just Googling AP Calc BC 2016 FRQ number 1 so you can follow along better. Additionally, yep, that's about it. I've written down the key information from the question on the paper, as you can see. So let's get into it. So part A says estimate R prime of 2. Show the work that leads to your answer. Indicate units of measure. Now, R, if you can't see, R is the rate at which water is removed from the tank. And we don't actually have a function for it. We just have a table with values. So that's why it's telling us to estimate R prime of 2, because we can't actually find the actual value. We can just find an estimate. So R prime is asking for the derivative of R at a specific point. That's the slope, the instantaneous rate of change, or the slope of R at a specific point, and that's 2. But since we just have this table, all we can do to average is we can just take the slope of of values in which 2 falls between. So we could take the points at 1 hour and 3 hours and find the slope in between those points, and it'll give us some estimate of the slope at 2, but it won't be perfect, but it's the best we can do. So what I'm going to do is we're going to find the slope. We're going to assign the slope, or the rate of change of the line, between times 1 and 3. So what does that look like? That looks like R of 3 minus R of 1 rise divided by run, 3 minus 1, equals, what does that equal to? 950 minus 1,190 divided by 2. And then you just use a calculator for that. I believe the answer, let me get my calculator out. Technical difficulties. Okay. 950 minus 1,190. Divide that by 2, and you get negative 120. But what would the units be? It's a good question. So essentially, we're taking the rate of a rate. So it's going to be liters. Since we're taking the rate of a rate, it's not going to be per hour, it's going to be per hour squared. So that would be the unit, and that would be your answer to part A. Okay, moving on to part B. It says the total, use a left Riemann sum with the 4 subintervals indicated by the table to indicate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or an underestimate of the total water removed? Give a reason for your answer. Okay. So, removing water is the integral from 0 to 8, because we want the change, and you'd find that with a definite integral from 0 to 8 of R of t dt. But we're just given this table, so we can't find the actual value of this integral. We can only estimate it, and they tell us to do this with a left Riemann sum. So let's do this. So we're going to say that's about, this pen is not working very well. So we're going to be essentially using rectangles, right? The x value, or the length of the rectangle, is going to be the change in your time, whereas the height of the rectangle, your y value, would be the function itself. So first of all, we have the change from 0 to 1, so that's just 1 times, we're using the left endpoint, so 1340, plus, now we'll use from 1 to 3, so 3 minus 1 is 2, times 1,190, plus 3 to 6 is 3, times 950, plus 6 to 8 is 2, times 740. Does it tell us to actually? Yeah, it says estimate, so I think we should plug this into a calculator just to be safe. I don't know if we actually need to, but if I was taking the exam, I would plug it into a calculator. Plus 2 times 1,190 plus 3 times 950 plus 2 times 740. So I got 8,050 liters. And lastly, is this an overestimate or an underestimate? Well, let's think about this. So we have a graph of our function. And we know it's decreasing. So it looks something like this. And we're using endpoints at specific times. So we're using this. We're splitting it into certain rectangles. And for the height, we're essentially using, so this is going to be our length values right here, but our height values are based on the left endpoint. So this is what our rectangle is going to look like. And as you can see, it goes over the graph. So clearly this is going to be an overestimate. An overestimate because the function is strictly decreasing. Strictly decreasing from 0 to 8. Which it tells us in the question, by the way, and you can also see that from the table. Okay, so part C, we are asked, use your answer from part B to estimate the total amount of water in the tank to the nearest liter at the end of 8 hours. Something I probably should have written up here is that it starts at time t equals 0. I'll just write it here. There are 5,000 liters of water in the tank. So what is it asking for? The total amount of the water in the tank at the end of 8 hours. So what we're going to have is we're going to have our initial 50,000 liters plus, so plus our change. So R of t is the rate at which it's removed, but we also need to consider the rate at which it's added, which is W of t. So plus the integral from 0 to 8, because we need the change, which is given by the integral of W of t dt, plus, minus, well, we just found the value is 8,050. Because that's an estimate for the integral from 0 to 8 of R of t dt, which is the amount of water that's removed from time 0 to time 8. So we're going to need to use the calculator for this, especially to find the integral from 0 to 8 of W of t dt. So we're going to need to math 9 this, which is how you'd find the definite integral on a calculator. And I'm just going to type in integral from 0 to 8 of 2,000 e to the power of negative divided by, I think, 20. So I get, when I do this, I get 7,836.195. I'm going to go to 3 decimals. So this is 7,836 point. I'm just going to write out 3 decimals, but for the sake of a correctly rounded answer, I'm storing the entire thing in my calculator. So now we just add 50,000 to this. And then we subtract 8,050. And I get 49,786. And what does it ask us to go to? It says to the nearest liter. So I got 49,786.19. So we're just going to go down to 49,786 liters. Should technically be an approximation sign. This pen is dying. Okay. Hopefully that part made sense. And now we have the last part of the question. Part D. For 0 is less than or equal to t is less than or equal to 8. Is there a time t when the rate at which the water is pumped into the tank is the same as the rate at which water is removed from the tank? Explain why or why not. So, let's see. So we're basically asking. We're asking if W of t is equal to R of t. Is what we're asking. And so we're essentially asking if we subtract R of t over, we're asking if W of t minus R of t is equal to 0 at any point. And what's jumping out at me right now is that we need to see if it's going to be equal to some value at some point. So the theorem that's screaming to me right now is the intermediate value theorem. So, and we need to see if it's equal to 0. So we basically need to see if it crosses the x-axis. Now, we need to prove that W of t minus R of t is continuous on the interval 0 to 8. And we can do that because R of t, it tells us, is differentiable. So it's also continuous. Actually, that'd technically be a closed bracket. And then W of t, we know the function. It's an exponential, so we just should write like W of t is a continuous exponential. Okay. So now we can use the intermediate value theorem. So we need to consider the endpoints. And if there's a change in sign, that means that W of t minus R of t must have hit 0, and therefore is equal to 0, and therefore they're equal to each other, the rates at which water is put in and taken out. So let's think. So we can define at 0. At 0, the rate at which it's added, W of t, is going to be equal to 2000 e to the 0, essentially, which is just 2000. And then R of 0 is going to be equal to 1348, as tells us on the table. So that means W of 0 minus R of 0 is equal to, what is that, 660? Yeah. The important thing is that it's greater than 0. So W of 0 minus R of 0 is greater than 0. Hopefully you could see that. Sorry. Okay, now we're going to do the same thing, but with 8. Okay, so W of 8. W of 8 is equal to 2000 e to the negative 64 over 20. We're just going to use the calculator for that. (2000 e to the power of negative 64 divided by 20, which is 81.524. And then R of 8 tells us in the table is 700. So W of 8 minus R of 8 is equal to, it's less than 0, that's the point. Okay, so now here's the big kicker. So we have to write all this. Since W of t minus R of t is continuous, continuous 0 to 8, and W of 0 minus R of 0 is greater than 0, and W of 8 minus R of 8 is less than 0. This is less than 0, by the way. I'm sorry for the awful handwriting. W of t minus R of t must equal 0 at some point from 0 on the interval 0 to 8. So therefore, by the intermediate value theorem, so Wt is equal to R of t. Oh my god, this pen is dying. 1 second. Need another pen. I think this pen is pretty much dead. 1 second. Okay, I have a tamed pen. Sorry for that. W of t must equal R of t on the interval. Zero to 8. Okay, so there's kind of our answer. That was a long question. I'm sorry for the confusion and all the issues I had with the pen. Hopefully I recorded this fine. I was thinking, hopefully I recorded it fine and you could see the whole part of the question. I hope you understood it okay. And I'll see you next time. Thank you.